Hello and welcome to the channel. So we've got this Vox AC30. Remember, in part 1 we did an assessment on this amplifier and the tubes were cooked. The rectifier tube was bad, this amp was blowing fuses, and we had the capacitors here that were bodged up. The wrong size capacitor had been put in, and it was pushed up against the fuse holder, and they put some shrink tubing around the capacitor just to help insulate it. The bias was at 15 watts on the tubes, should be 12. So we are going to recap this amplifier, sort out the tubes, and we've got the dreaded standby switch with the rectifier, which is always a no-no, as we've seen in the last couple of videos. We just seem to be having this running thread with rectifier tubes and standby switches. But we're going to do away with this standby switch. We're just going to bypass it, and then the customer can't flick it on by accident. Well, what do you know? Soon as I start filming, up she comes again. Yes, I am rather busy here, you know. Right, we're off the wide-angled lens now, and we can see this board here that we've got, and you can see the camera moving about because Pink is shoving it everywhere. And there, yes, Pink, thank you. We're busy. So if we look here, we can see where this capacitor was, and we've got all this gunk to clean off. I mean, we've got the capacitors to fit there. We've got, I think that's 220 at 50 volts. I've found the capacitor out a few days ago, but I think that's 220. We've got the cathode resistors here, which have got to be changed depending on how the bias lies when we get all this sorted out. We've got 10 microfarad here, which I'm going to replace with 22. And then we've got a 33. I've already taken out another one of the 10s, and I've taken out one of the 33s there. So we're going to just completely recap this amplifier. I'm going to get this board back in. We've got a new rectifier tube, a Softec. We're going to disconnect the switch, as I've said. So quite a bit of testing to do. I don't think these coupling caps will be leaking, but we'll have to check to see if they are. Right, I've got the heat gun here because this is hot glue. I know it is because we had to melt it before to get that mess out. If you've not watched part 1, then go and give it a watch. Get some more support under this board. We don't want to be scratching it on the edge of the chassis. Can't really see very much, only my hand. I probably need to just go over the top of it with the camera. But anyway, there's the gunk that's come off of there. Just being careful not to just lift the camera up, not to scratch this board either. That's why I tend to use these screwdrivers with the wider rather than an electrical screwdriver, which is a bit sharp and cuts into the board if you're not careful. This thing's quite blunt, so yeah, it works pretty well. Now we've got still struggling to see a bit, aren't you? just go a bit higher up and over. Now we've also, it's also run into the fuse holders when they put this stuff on, this glue. So we need to try and get it out of there as well. There we go. See, dear, oh dear. Gunk everywhere. So what we'll do now is get some alcohol in there. Now we've loosened it all up. Right, we're getting there with it. There's some good comments coming in on the Fender Vibrolux video. General consensus is that it would be better to replace the board, which, to be fair, as I pointed out, if it was mine, that's what I'd do. But there's always people that, you know, won't want to replace the board. And as I said, it was an experiment, and we will find out in a few months when we test it again if it's actually worked. Bit of a myth buster, but at least when we test it again, if it's leaking again, then we'll know that it's fact that it doesn't work. And if it doesn't leak, then we'll know that it is worth doing to someone who, you know, who wants to keep the amp original. But yeah, some really good constructive comments there, and that's what we like on the channel. Need to get it all out of this fuse holder, because we'll have trouble with it, the fuse conducting on the side of it if we don't. It's a real mess. This is really no need to put all of this on here. By the time I've done messing about with these two, you know, getting this off around these two capacitors, I could have recapped the amp. But it looks a mess, and we can't just leave it like that. And as I said, we need to get it out of that fuse holder. Big clamp of it there. Yeah, that's got that out, I think. Yes. I think we'll get the soldering iron on now, and we'll remove this. This was the lead, if you remember, that was left over from the from that axial capacitor that was botched in there. Let's just zoom in a little. You see a bit more of what I'm doing. Trying to film a little bit more now that I do. Let's try and make the videos a little more interesting, and so people can see how things are done. I'm sure a lot of you have done this before. So we got silicone and hot glue on this one, and you can see we have on the others. If we look at this is silicone and this is hot glue here. So we've got to get all of that off. We've got to clean these up as well here. we've already removed those, but yeah, still full this fuse holder. Now I've had a few comments about the audio quality on the demos at the end of the videos, so that's something I want to try and sort out and improve. One or two people said that you can hear the electric guitar acoustically, you can hear the strings and so on. Let's get rid of that glove. So we're going to try and sort that out as well. Another thing that I've been trying to sort out on the channel is the adverts. So YouTube, and it's worse on the longer videos, YouTube have been putting automatic mid-rolls. Basically, it's AI or what it is, kind of decides where it thinks it should put the best adverts. And I don't want to people complaining there was just too many adverts, so I decided to go into the editor and have a look, and my word, here we're really going for it. So what I've started thinning them out now a bit more, especially on the bigger videos. And it you know, for me it's a bit of a two-way thing, because the adverts, obviously they make money for the channel, but obviously too many of them, then that just makes the videos not interesting. So I've kind of got to strike a balance with that. So it's but yes, the thing is, the more the channel grows, the less adverts you need, because there's obviously just more people viewing the videos. So you just get, you know, if you've got twice the amount of people viewing the videos, then you could get away with half the adverts and still get the same money. Right, that's got that out. Now, when I did that fender video, obviously I filmed some of the board cleaning, and here we are again filming board cleaning, not quite on the same scale. And obviously I speeded some of that up and obviously put some music to it, which is what a lot of people do on their channels. But just let me know in the comments what you thought of that. And because what I'm trying to do is get feedback to improve the channel and get it out of the, I mean, there will always be people that don't like certain things, and that's just human nature. But it'd be nice if I kind of got some feedback on things like that. So yes, but here we are, board cleaning again. Board cleaning. Pink's just bored. She's not cleaning, she's just bored because she's not getting any food. You can hear her purring away, watching me clean this board. She's fascinated by it, actually. Although the only thing that really fascinates Pink is treats. Now, there could be some substance to why Pink always appears when I start filming, because every video that Pink appears in, she gets 20 dreamies. If you live in the States and you don't know what dreamies are, they're a cat treat, and cats go nuts over them. So Pink gets 20 dreamies per appearance. So she's rather keen to gate crash them, for obvious reasons. Right, that's starting to look more like it. It is. Be so careful not to scratch this board. It's I had 1 or 2 good comments on this amplifier as well. One watcher commented on this bias that he puts a couple of 168 ohm resistors. Remember, these resistors are in parallel. These 2 resistors are 100 ohms, but they're obviously parallel in 50. So he puts a couple of 168s in there, and that roughly gives the same resistance as in the original AC30s. So we'll be having a look at obviously biasing this amp later in the video. Right, that seems pretty clean now, or it's 99% there. So what we're going to do now is we're going to get these other capacitors out. That one's pretty easy. There's not a deal of anything holding that one. This stuff comes off pretty easy. This black stuff that we've got on here, this gank. Right, we'll just get these. I'm just going to tip this over and suck the solder off those, and then we can get them out. Right, I don't know whether these capacitors he put in here, whether the leads were just too big for this board, because I've had to drill them out. Just couldn't get them out. The leads were broken off in there when I actually started cleaning all this off, and yeah, so I've had to drill those out. I'm afraid they were a bit of a mess, so I don't know what he'd done there, but anyway, we've got that out. We've got the bypass cap out here, and if we go across, whoops, and I've got all the other caps out. We've just got to clean now, or clean all this mess off here, and then we can get the new caps fitted. I've cleaned at the back of the board. You probably can't see very well in here with this chassis, but I've cleaned all of this up. It was all, we're covered in flux and whatnot, so I've cleaned that off. Well, they're all looking good, those tracers. Soldering points on the top here, but they're not actually connected to anything. But unfortunately, there was so much glue and crap on there, I'm afraid the glue's just lifted those, and those 2 are okay, but that one, I'm afraid, those 2 made a bit of a mess of that. But it's fine, because we can fasten them. The tracers, the connection tracers are on the bottom, not on the top. So, but yes, not ideal, but it's not a big deal. So let's get this start getting up these now. We'll get this all sorted out. Remove this. We'll just soften it up a bit. Right, let's get some alcohol on those, clean those up. Right, we're working us way through this now. The problem is this silicon, this black silicon, is really difficult to get off, and the worst part is this is a double-sided print board, and it's got onto the tracers, and that's a bit of a problem, because when you're scraping it off, you've got to be so careful not to damage those tracers. Literally applying the lightest pressure to get this off now, and it is softening up with the alcohol, but it's taken some time to do it. And I know taking a screwdriver to it doesn't look great, but I can assure you I am really being light with it. It's literally just using the corner a lot, barely pressing on, because normally you can put a a razor blade or something under these and lift it off, but I don't do that on here because I'm frightened of lifting the trace off, which would be catastrophic if we did that. Well, not catastrophic, but we'd have to then start repairing that, and then it just becomes a mess. So, and normally you do find silicone on the boards, you do have to do a bit of cleaning, and that's fine, that's all part of the job. But when you've let it run onto tracers and things like that, then that's not fun. And I don't think we're going to completely get all of that off. Got 99% of it off. It's just, that's not really an issue though, so I think we'll leave that now. I think we've scrubbed on that more than enough. Right, I've got one in, and what I've decided to do with the silicone on these, because I don't want to get it all over those tracers again, I've just put a very thin film of silicone around the edge of this capacitor. So we don't really want to get it on that part if we can help it, but just round the edge, and then just sat it down, seated it, obviously soldered it in, and do you know what, that, you can see it there, that will hold it just as well as putting all that gunk on there. So yeah, so we've got that one in, and I think that'll be absolutely fine doing them that way. Oops, there you can see just that, just enough to stick it down, and that will be ideal, I think. Just stick that there, of course making sure that I get it in the right way around, because you know what a plank I can be at times. So we'll try this way. I've not done it this way before, but I was trying to look at doing things a different way, but this has kind of forced me to do it, because I just don't think it's a good idea to be putting silicone on tracers. Well, let me know what you think in the comments. Say it's a bit hard for you to see in here, and the two sockets are obstructing as well, which isn't helping. Right, so this one, there's a trace right under more or less where that's sitting, so I've just put a little bit of silicone in between those caps there where there's no trace, so that should hold that in place pretty good. Right, there we go. So we've got all the caps in, and this one, that is the right diameter exactly for the circle, and it isn't touching the fuse holder, but by gum, there's not much gap between this and the fuse holder, but that's the way it's designed, and it's the correct capacitor, so certainly better than it was before, isn't it? So yeah, that's all that done. Now what's left is I've got the cathode bypass capacitor to go in there, but I've noticed that you could put an axial in there, and I don't know if I've got one. If not, we'll put the radial in, but the reason I was thinking of putting the axial in, because it sits much lower, and if we sit the resistors up like they were before, it'll keep the heat off it. But yeah, that's all we've got left to do now. Then we can get the board in. We've got the two cathode resistors, and I may just put the board in and put just a couple of nuts on here, and bias this amp, then take the board out and do the capacitors properly. These are two-sided print, as I've said, but I'm not going to risk soldering it from the top. I'd sooner solder it from the bottom. So we're going to do those, And then we've got these 4 screen resistors to remove, these 100 ohms. Just don't know why they even bother putting them in, they're so low. And we're going to increase those to 1k. Now the fact that we're increasing those by 10 times, they obviously need to be a little bigger, because there's going to be more voltage across these, so we need there'll be more current, so we need a slightly bigger resistor there. So we're going to use these, and these are 1k metal films, metal oxide, sorry. So we're going to use those for they are considerably bigger, but we really do need something bigger. It's no good putting the same size resistor in, because it'll just burn up, and it'll burn up when this amp's cranked up flat out. Now most of the time this amp won't be used flat out, but I have to put the right components in for this being used flat out, because it can be used flat out. That's what I'm trying to say. It's late at night now. It is 12:10. I've been on the night shift doing this, and I'm just knocking off now, because that's enough for today. Been at it all day. Not this amp, but we've been at editing videos. One thing, did a quick repair on a Fender Supersonic 22. It's turned out to be a reasonably quick repair. Just a set of tubes and a bias needed on that. So I didn't bother filming it. It was only a quick thing. Just got it done and off the bench so we could get onto this. Right, we've got the board back in. Obviously we've got all the caps done. We changed the screen resistors from 100 ohms to 1k, and obviously we've put a bit higher wattage resistor in, because the wattage of resistor that they had in before at 1k would just burn up when this amp's cranked. Got 10k grid stoppers in there, gone the upper end of those. So we've got those in just to help with blocking distortion and any harsh trebles and things. So that's what I've gone with there. We've disconnected the standby switch. Easy, simple enough. We've just obviously pulled the leads off and then just connected from the transformer straight to here. Those are coming off again though, so because we're going to be doing something else on there in a little while. We've got the cathode resistors here. So what I've done is I've made some leads to go up, and I've put a hook on the top of those, so the resistors just drop in. What that's done is raise them higher as well, so we're getting them above this capacitor here and just above this one, so we've not got the heat from the resistors baking the capacitors. And obviously, you know, if this amp needs retubing again, when the next guy comes along, he can just lift out the resistors, soldering iron on, lift them out, and then if he's got to change the bias, or I have, or whatever in years to come, whatever, it's just for the next guy that comes along. We've done that. Just and it allows me to get the bias right on this amp without having to take the board out, because I've got to get the board in to get this amp running. Then I jumper the bias resistors in, and then I've got to take the board out again to jumper them, to solder them in. So those leads, and they're quite sturdy. So that's what we've done there. So ready to fire this amp up now. Now I've got a set of test tubes in it. I've not put the original old tubes back in to test it, because we weren't 100% sure what was blowing the fuse on this amp. We think it was the rectifier tube most likely, but just to be sure, it would be a bit daft to put those back in, given the fact that we've done all this work to it. We don't really want those in anymore. So we'll get a power lead and we'll fire this up and see where we are. Bring it up slowly on the bulbs, obviously because of these new capacitors. Right, we're off. So start with a 40 watt bulb, and and you can see if we go up you can see the voltage going into the amp now. We've got 139 volts and climbing. Got 91 going into the amp. So that's pretty good. Let's just put another 15 in. So we've got 55 watts now. That's going up. Cooking on gas. We are cooking on gas. Drawing 150 milliamps. There's 120 volts going in now, so should be getting sound soon. And that's the voltage coming straight off the cathode of the rectifier socket. Yeah, we've got sound, so that's looking good. So we'll go up a bit more. It's good, we've got sound. 187 now, we've got 125 going in, so we can get both of those on together like so. So we'll start we can start upping the voltage of the bulbs a bit more. Now we'll up the voltage. There we go, 100 watts in there now. That's going up nicely. 140. Drawing 290 milliamps, just up to 300 milliamps now. Good. 160. And now up to 200. $282 with 187 going in. 370 milliamps, that's quite high. $250 watts of current limiting now. Got 212 going into the amp. 324. So we brought those capacitors up nice and steady. 300 watts of bulbs. That should give us, that's giving us 224. See the voltage is going up. Right, we've got the valve rectifier in the GZ34, so we just wait for that to build up. Plug it in. So used to pulling out the plug. What's going wrong there? Why have we got no power? I think the fuse may have blown because I've reduced them while we're testing. I think it's popped it. So yeah, I put a real low fuse in there while we was working on the bulbs in case we had a fault, just to give us some extra protection. It was only 630 milliamps quick blow. It should have been 2 amps slow blow, so I'd forgotten I'd still got that in there. Now then, let's check the bias again. Still 11.35 going across that resistor. So we now had 35.9 milliamps per tube with 5% off for the screens. 331. 11.89 now they're running at, so that'd be acceptable, and that's with 250 ohm resistors in there, and that's 70, giving us 75 ohms, gives us 11.8. So that's looking good. So the next thing we're going to turn his attention to is this rectifier tube. Now on the Fender board clean video we'd got the same problem with the rectifier there, and we put on a couple of solid state diodes, 1N4007s, between the feed coming off the transformer and to the anodes. We put them in series, and I made a bit of a speculation that I thought that they'd increase the voltage, and but I was wrong, and was a bit of a plank, as Jeff pointed out, who comments regularly on the channel and is extremely knowledgeable, and he pointed out that that's not the case. They don't increase the voltage at all, because you still got the resistance of the tube before you get to the cathode on the actual tube itself, where it's rectified to DC. I don't know, I just assumed that it had increased the voltage, but it actually doesn't, and I think I just got my figures slightly wrong somewhere there. Plus we got that rising wall voltage from when I was doing it in the morning. The wall voltage has gone up 12 volts, so I think I just got that a bit round my neck there, but I was quickly corrected on it, and rightly so. Some of the watchers of the channel keep me on my toes, and I actually appreciate that. So we'll what we'll do now is we're going to take these wires off, and we're going to wire some diodes in series on the rectifier tube socket now, like we did on the Fender, and I'll just go through how you do that. Even though we've done it on the last video, I'll go through it once more. Right, I've got the diodes on, and same as the last video, pin 3 and pin 5 on this tube socket are no connection. So we've used pin 3 to connect the wire on, and then the diode goes in series to pin 4, and likewise with pin 5 to pin 6 on there as well. I see it beginning to go up now. Just put the bulb in there, and there we go. Let's pull that out. There we go. So we've got 305 now. We're on there, and we're still on the bulbs. There's no problems there. So what we're looking for now is the voltage that we had before was around about 345 to 348. So we're going to come off the bulbs and see what we've got. And we've got 352. And dropping. But when we did this earlier in the day, because we're on the night shift now, we'd only got 231 volts. But now we've got 239 volts. Right, so I've got the amp running okay now, and everything runs. We've done some bias tests. We know roughly where we want to be with the bias resistors. We've had the test tubes in. Now we're looking at putting the new tubes in, the new output tubes. Now I'm going to do something a bit different with this amp. We're going to put in some CV4043 tubes in this amp, and these are a military grade primer tube, and these are really good tubes. Now to do this, we've got to just wire the bases slightly different. They're almost the same as the EL84, but not quite, so we've got to wire the bases different. But other than that, now I did quite a bit of testing just to see where we were with voltages. So if we go in here, you can see we've got 350 volts maximum plate voltage. Anode is plate, we call that anode in the UK. And the dissipation of this tube is 13.2 watts, which is ideal for this amp because it tends to run the tubes a bit hot anyway. Now the screen voltage is 310 volts. I'm about 7 volts over with this amp, but considering that most EL84s are run over volted anyway from their maximum limits, and if I was running EL84s on this, the plate and the screen would be over, although that's normal for those these days. The plate, because remember this is plate to cathode voltage, so plate to cathode voltage is somewhere around about 340 volts, so we're under there and we'll be about 6 volts over. Now we'll be 6 volts over on the screens, but only at idle. So as this amp gets louder, the screen voltage will reduce, and it will reduce below 310. So it'll only be when this amp's idling that it'll be 5 or 6 volts over. Generally new old stock tubes are more expensive. These tubes aren't, they're not particularly expensive, so we're going to put these in and see how we go with them. So what have we got to do then to get the voltages, to get the connections right on here? Let's just zoom in a shade, shall we? So let's start from pin 1 then. So if we just go in here, that's what we need to look at, don't we? Let's get that into the center a bit more. There we go. So let's look at pin 1 is grid 1, pin 2 is grid 1, so they're connected together. So EL84 is pin 2, so we don't need to change that. Pin 3 is cathode, so is the EL84. Heaters are 4 and 5, so again the same. No connection on 6. Pin 7 is the plate, that's the same as the EL84. Pin 8 is the screen grid 2, so we need to move the pin 9, because it's pin 9 on an EL84, the screen, so we need to move grid 2 screen to pin 8, and then the suppressor grid is grid 3. Now in an EL84, the suppressor grid 3 is internally wired to the cathode, but in this tube it's not. So all we need to do is take a loop and connect pin 9 to pin 3, and that's all you do with these tubes. You move pin 9 to pin 8 and then connect pin 9 to pin 3, and that's it, and these tubes will run. Right, I've got those sockets rewired now, and we will have a bit of a gleg. So we've got pin 9 here, and we've moved the screen grid 2 that was on pin 9 to pin 8, and you can see I've done that there, and on this tube as well, this one and this one. And then we've bridged from pin 3, which is the cathode, to pin 9 here, because that's grid 3 and that needs to be connected to the cathode. You can't leave that floating. If you do, you'll get all sorts of problems. And then we've just linked each grid 3 along there, so the link comes across here, goes to there, then goes to the cathode. All the cathodes are linked together, and so on. So there we go. So they're wired up and ready. Pretty easy to do, really, that. So now we're going to get the tubes in. So there we go. That's the tube in question. CV4043. These are military grade Brymer tubes. So, and we just pull that off of there, like so. And yeah, brand new tubes, new old stock, a result. So we've got those tubes in, and I'm on 250 watt bulbs. We've got 300 watts of current limiting. We've got the 150 ohm resistors in parallel giving us 75 ohms, and we've got 12.67 watts. So these tubes are drawing some pretty hefty current, which again just adds to my statement of you must bias them, cathode biased or not. You must check the bias. You can't just shove them in. So 12.6, that's on the bulbs. So we need to go down again with the, we need to go up again with the resistors. So I'm going to try at 180 ohms in parallel, and I think they gave us about 11.8 watts, something just shy of 12 watts anyway, on the test tubes. So let's see what we get with these tubes. We've got the 180s in there now, so that gives us 90 ohms instead of 75. Now if we look up there, I'm monitoring the screen to cathode voltage. I know I'm not going to go over on the plates, and I know we are going to go a little bit over on the screens, but not very much. Hopefully, I think we'll be fine. We'll go over a little bit. So now I'm going to come off the bulbs, and we're under with that 306. Where's the bias at that? So let's check. 17.4 across the resistor. Divide by 90 now. Gives us 109. What? Divided by 4. 48.3 milliamps. Take away 5%. 45.9 milliamps. So that's quite high. 316. 14.5 they're drawing. 14.5 with 90 ohms, and we've got 17.5 volts going across the cathode resistors. When we had the same resistors in with the test tubes, we had 11 volts going across there. And if we do the maths on just on the current, so 11 divided by 90 divided by 4 is only 30 milliamps a tube. So these tubes are running 15 milliamps more than the test tubes were. So that tells you that if we'd have just put these tubes in this amp, they would have fried. Without checking the bias, they would have fried, and with the original 50 ohms of resistance, they would have really fried. So you must always check the bias on cathode biased amps, no matter what you read on the internet or whatever. I've just proved that you must always check the bias. So we need to come down again. We need to go up again, don't we, a little bit more, because 13.5 is our target, and although we've got nearly 240 on the mains pushing up there, so we're roughly around right with that. 308 on there, we should be 310. We're good 20 volts under on the plates, and we just about hit the mark there, but we're a watt over on the dissipation, which is not massive, is it, compared to most tubes were biased and the tubes that were in this, but we'd like to just get that down a little bit more. So we might, I don't think I've got any 190 ohm resistors. I've got some 200s though. Right, so I've got the 200s in there, and that, look where the screen volt's sitting, screen to cathode, just about a volt over, and that's just because it keeps going up on the wall. So yeah, so 18.36 is going across the cathode now, and if we divide that by 100 now, equals 183 milliamps. Divide that by 4 is 45.9 milliamps. Take away 5% for the screens. Times, just need our plate volts, 13.8. So they're on the nose at that, just on the nose. 13.8. And we've just made, we're a volt under now, we've just made those fit. And we're drawing 590 milliamps with the test tubes in. We were drawing 600, so we seem to have come down on that. The power transformer is really cool as well. This amp has got a great power transformer on it, it really has. Right, one of the problems that you will have with these tubes though is the original retainers are too tall, because obviously the EL84 is a taller tube than these, so I found some more, put those on, and put the other ones with the amp for the customer in case he ever wants to go back to EL84s, or in years to come he sells it and someone wants to put it back to those. They've still got the original retainers. And there we go, all finished. Got the resistors in there, so we're all done and all good to go. So we're going to get this back in the case, and we are going to have a blast on it. Right, we've got this Vox AC 30 all plugged in and sorted, and I thought we'd do this demo a little bit different than we do the others. So we've got the camera focused on the controls of the amp. We do this occasionally. So we're in the normal channel at the minute. So a lovely sweet tone. Let's go in to the brilliant channel. You see the amp is very bright. There we go, all the treble in, so just take some out. out. Very aggressive, that cut. So let's try the Vibrotrem channel. As I noticed as well, there's the grub screw's missing out of this pot, so I'm just going to have to find a grub screw before I give it back to the customer. So there we go. I think my favourite channel is the Brilliant channel on this amp. It just sounds fantastic. So much scope as well on there with the EQ. So there we go, the Vox AC30, and what a lovely sounding amplifier. That just on the Brilliant channel, that just sounds absolutely amazing. I've always liked these amps on the Brilliant channel. I've never really much bothered about the other channels. Everybody's different, you know. Some people like the vibrato channel, some people like the normal channel, but for me it's the Brilliant channel. So there we go, that'll do it for this one. So thanks for watching. You all take care, and I'll see you all in the next one. Bye bye for now.